I'm Sanjeev, I'm from FIU, and I'm here to present NDNSEC tools and trust bootstrapping. Okay, for this as a prerequisite, I hope most of you should have NDNCXX downloaded and installed. So we'll go through the NDN security, NDNSEC command line tool suite, as well as probably a basic overview on trust bootstrapping and certain demos to wind up the session. Okay, a quick introduction to NDNSEC. It's a command line toolkit to perform various NDN security management operations. NDN security data are stored and managed in two places. As listed, it's public information base and trusted platform module. I hope I'm audible in the back. Yes, okay. And you've been seeing various ways of naming conventions and stuff. Well, the usage for NDNSEC is as depicted in the slide here. Okay, before we go ahead, just small pointers about identity, key, and certificate, what each of them mean. So identity is a named entity in NDN. You have keys owned by the identity, and each entity or each identity can have more than one key. And certificate, about which you'll have more details later after this presentation. It's used to certify a key. You've heard a lot about certificates from morning. Some real-world identities are as shown in the second bullet. It could be highly flexible, like NDN, EDU, UCLA, allies for one of the, and you can have various granularities as depicted and presented earlier by most of them. Okay, I thought I'd make this a little more interactive, so probably we'll do some hands-on examples and try to understand how to use NDNSEC. So if you have NDNCXX downloaded and installed, probably we could start off. So these are certain commands that we have under NDNSEC. I just to get more details or to get the complete list, you can try to type in NDNSEC followed by help. It should give you a detailed explanation as to what are different commands you have and how it could be used, like the version list to display certain public information, and get default to get details about get and set defaults and other things. So this slide here shows certain identities that already existed when it was captured. Probably I'll show how to create an identity or get your identity. Okay, so you can try the command key generation to create your key signing key, so to create your pair of public and private keys. Okay, obviously you need an identity following this, so let me create one of the identities. But probably because we are here at ICN, I'll call it 2018 and in room 142. So that should show you a self-signed certificate with this identity as ICN 2018-142. So now getting back to this slide, which shows the command that you can use to view the existing identities and keys and certificates. We can have various versions of this and clear it. So probably we could start off with this gives you the various identities, and the one that I just created should be seen right here as the default identity. And if you don't want as many details, probably you just could use NDNSEC list to just list the various identities you have, and the one with the star basically shows you the default identity. Okay, we just saw how we create our own key path, and this is basically as depicted a self-signed certificate. And more details about how to use NDNSEC is available in these links that's shown on the slide. And you have man pages as well as source code of NDNSEC as displayed. Okay, now moving to the trust bootstrapping section. Uh, all of us spoke about, the people who spoke, Peter, Alex, or Lucia, spoke about a trust anchor. But what does a trust anchor actually mean? Trust anchor is someone who has, in which trust is assumed and not derived. So you that a trust anchor could be a trusted self-signed certificate. Uh, you can see the example on this right, as in you have UCLA administrator, probably UCLA self-signed, which has to be uh, trust anchor, or you could have trusted non self-signed certificates, which could take the role as a trust anchor. Uh, as in, you could that you could trust in the CS department, which is not self-signed but invokes the trust from the trust anchor UCLA, probably which is self-signed. And this trust anchor is necessary option for properly validating the packets as described in the trust schema presentation provided by Alex. Uh, the trust anchor is usually done offline. It's not and is shared by certain secret means or other means to uh, means, and there could be various ways to configure your trust anchor. You could the most trivial option would be to hard code in the code, but it's not something that's to be uh, adhered to. So we have certain ways to configure the with the trust schema. We can either have one or multiple uh, trust and one or multiple, and you have directly defined which is a static trust anchor of page 64. You can have indirectly using file names. You can see an example on the right with from the validator.conf syntax showing how you could have a file name uh, defined, and which makes it an indirect way of configuring a trust anchor. And you could have double indirection using probably directories, having storing the key, which store the keys. It could be static or dynamic because there are certain times wherein the certificates get refreshed, and you add in a refresh period. Uh, Probably could be in hours, minutes, or seconds, and so you get that flexibility of uh, uh, adding of making a dynamic way of configuring, and you also have one special option called any, which ideally shouldn't be used. Which if any is used, you kind of disable the security because you prevent validation from taking place. And let's to make this bootstrapping process a little simpler. As in to explain this a little in easier terms, probably we could use an example. The example here on the slide as depicted is a smart home scenario. You could have basically have two entities, a controller and the device. By bootstrapping, it's basically the onboarding process. Wherein you want the device to trust the network, and vice versa. Wherein you want the network to trust the device that's trying to access the network. So the controller here could be a simple phone or a laptop with, um, and the naming convention is as displayed. You could have various uh, devices, and depending on the granularity of defining them, it could be a camera that's present in the living room, and it could be even a television in the living room, and so on. So, like I've been speaking about, there are certain goals and steps used in for which the bootstrapping is to be done. Like I told you, it's about trying for enabling the device to trust the network. Uh, that with and to automate this, we try to automate this process so that you have minimal user intervention, and the more details about how the process happens is would be in the next in the coming forthcoming slides. Specific to this example, every home has a global unique name along with the keypad. I showed you demonstrated as to how a keypad could be created, and it could be there. And the certificate serves as a local trust anchor. You saw how a self-signed certificate was created, and uh, the other goal of basically bootstrapping is to enable devices to be trusted by the network. So it's a two-way uh, trust that's to be established. Uh, for this to be uh, upheld, you need an anchor signed certificate, um, and device has a key signed by the trust anchor, and the trust anchor, like I told you, is uh, issued offline and by to the controller, and we'll see the process further in the coming slides. There are other requirements as well for the uh, bootstrapping process. This it's basically to establish mutual trust, and uh, by doing this, you can prevent the device from joining the wrong network. You can prevent certain attacks, be it replay attack or impersonation, and also try to prevent malicious devices from trying to join the network. Um, we saw the controller and the device in the previous slide, and pretty much showing up the same. Okay, there are certain assumptions that we take into consideration when talking about bootstrapping. There is some form of physical connectivity that exists between the controller and the device. Um, it could be in the form of Wi-Fi, Bluetooth, or any uh, thing of that sort, and it's, the controller obtains the bootstrapping key. So the bootstrapping key is known to the controller before the bootstrapping process starts, and this could be by various means, other plan means, like a simple scanning of a QR code or a barcode or something of that sort. Well, this figure here or the slide depicts the steps that are involved in bootstrapping. So the device basically starts off the process. It initiates the process by broadcasting and a request or the bootstrapping request. Uh, and in the request, like I told you, the bootstrapping key is already known to the controller by out of band means. The controller, in response to the interest passed by the device, bootstrapping interest request passed by the device, replies with the local trust anchor and gives the device uh, the local trust anchor's details so that the device can uh, uh, the device goes ahead to pass on the certificate, requesting for a certificate, uh, and sends its public key for signing. The in reply, the controller uh, sends a public key, the certificate, and which is signed by the anchor, trust anchor. Well, like I told you, this process could be used for preventing certain attacks. Could be a replay attack or impersonation attack. For this to be realized, reiterating the process, device signs the first interest with the bootstrapping key, and then uh, the controller can authenticate the device, like by just verifying the key that which it was signed to perceive if the device that's trying to interact or join the network is a legitimate device or is just something that's fake, or and the device and controller negotiate a temporary symmetric key, which would be the communication key for the exchanges, and it's done by Diffie-Hellman process. The key is used to sign following packets and ensure that the integrity is maintained and both ends are authenticated. Um, Meanwhile, to prevent any kind of replay attacks or impersonation, there is some kind of random token that's passed on. It's like a nonce that's passed on either side, just to make sure that there is no attack being uh, being waged. Well, just reiterating the contents from the previous slide, you have the device and the controller. The device starts off the bootstrapping process by sending a request to start the bootstrapping, and you get the reply from the controller. Basically, validates the uh, uh, if the device is a legitimate device or not, and send replies with the trust anchor as well as a token. As in, when the device sent out the sign-on request, there was this. It sends it along with the token, which is randomly generated by the device, so that and the controller responds with with the previous token that it received from the device, and with another randomly generated token that so that the device, after receiving the data packet, gets to validate if it's validate the data, what the packet that it received, and following which the device sends out the request for a certificate with the same token that it received from the controller, signed with a temporary symmetric key, and the controller replies with an anchor signed certificate, which was requested by the uh, device earlier in the previous uh, exchange. Okay, now we'll have a quick demo of.
So first, do you have any question about this bootstrapping process? Yes, please.
So, um, if I'm at UCLA, there's a UCLA folder, maybe a UCLA CS folder.
Yeah.
I'm at home, I've got a home folder.
Oh,
If I close my laptop at home and I take it into UCLA and open it up, does its name change? Does it connect to the UCLA folder?
so that's first, that you, I guess you won't use this for this purpose because this is basically for an IoT scenario that you can like scan a QR code or have some physical button process to achieve the out-of-band mutual trust and then get a certificate and also learn the trust anchor. And for your scenario, basically is yeah, you cannot use this protocol for this purpose. And whether you need to change your name, it depends on your application scenario. So whether you want to have a new name there, it depends on the application needs, right? Hope answered the question. Okay, yes.
So I made the chart the local trust anchor instead in the trust schema, right? In the very beginning. So if we modify the trust anchor,
You mean the
bootstrap everything, bootstrap if we change the trust anchor.
in the current design, there's no trust schema here for now because the first round trip basically changed the trust anchor. So the controller give the trust anchor to the device. There's no trust schema here. So basically, you use the default trust schema, that is, you directly verify the signature.
She's asking what if later on the trust anchor changes? I mean, the trust anchor of the home changes.
Okay, I see. We don't have the design for that part, but I have some answers in my mind. That is, because previously you already issue a certificate in the second round trip to the device, so you know its identity, right? So when you want to change the trust anchor and assume that the previous certificate is still valid, then you can use the previous certificate to verify the identity of the device and issue a new anchor. No, give the new anchor to the device. Yeah, I will basically show how to insert the trust anchor into the validator config, so the trust schema introduced by Alex. So first, let's take a look of the config file. So it's a very simple rule that it filters all the data packets that with the prefix /home, and if the data packet its prefix is /home, then it will apply the checker against the keylocator. And here we have the extremely simple regular expression that will pass all the keys. And for the trust anchor here, I use the directory type that can load all the anchors on the specific directory. And here the folder name is called the anchors. So it's actually here. So anchors, in the anchor folder, I have two certificates now. It's a little bit small, but I can see one is Alice cert, one is the home anchor key cert. So basically, I run an application here. We call it producer. And as Alex just introduced, this producer will for the first time generate the data package signed with Alice key, and second, it use the home key to sign it. So, yeah. So one signed by Alice key, one signed by UCLA's, one signed by home key. Clear. I will first export the log file. And now this part I will call the consumer. Let's use the rules anchor config. That's what I just showed. Okay. So when we run this application consumer, and first the key locator says is signed by the home living room camera 01, and the validation succeed. This is because that in the folder we have the home certificate there, the folder I just showed here, and I run this consumer again, you can see we use a different key to sign this data packet, but the validation still succeeds. This is because that in that folder there's another certificate called the Alice cert here. This Alice cert is what I get from the NDN EDU UCLA Alice key. So now, if I, for example, if I remove this home anchor key certificate out of the folder, and I run this application again, it shows validation failed. This is because that you don't have the trust anchor. And in the bootstrapping part, you are supposed to get this anchor key from autofan means, or you based on some shared secret and learn this trust anchor. So that's a very simple demo, shows the idea of the trust anchor.
Don't go over it. I just will be very, very quick. Few twists for NDNSEC command. So here showed that there is a, let me just keep one terminal. That there are anchors, but there are some certificates and anchors, and you can see that it's just a simple text file with some base 64 encoding. You can try to decode this base 64, but then you get like some random garbage, like you not really see what's going on. This random garbage is actually a data packet, and there are tools in NDN library that the simplest way to see what's happening with this packet is to just dump the content of the data packet. And so Sanjeev showed you this NDNSEC list. And you can also list a specific thing and you can list this thing, and there's actually option to see a lot of details of the individual certificate that's been issued. So I'm just showing one of them. So it's just showing certificate, full certificate name. That in this case you can easily identify that it's self-signed, but also you can just match the key locator that's also kind of exactly the same as the key name. The prefix of that certificate is the key name plus the the certificate name has a few additional components. It has a validity period and the actual public keys. So with the tool that I was trying to show you, actually I was trying to show you two things. One is to just dump the content of the data packet, like this NDN dissect. I'll show you in a second. But it will just show the content in not really readable form. It doesn't parse fields. It just say this is the field number 15 and this is the content if it's parsable. And we have a tool called NDNSEC dump certificate, which can show some values of certificates that are stored, or like you can just give that certificate in a file, and it will dump whatever the content. So let me try, and I think I will need to. Okay, it will kind of seemingly doesn't do anything. It's kind of dumping the same thing, but we also have this pretty format, like with the -p command, and actually print out something meaningful, like extract the whatever data packet, and then like extract the name, extract the validity periods, and so forth. And like if we kind of to prove that this is Alice certificate, we can see the name, and to see the other home certificate that he moved to a different location, so just use the file that he moved. And you'll see that this one is actually some certificate, key, living room key, that was signed by, also self-signed certificate in this specific case. If it wasn't self-signed, you will see kind of different certificate name, and then you either already have the certificate or you do fetching in some way, like using NDN peak, for example, and you can also dump it.